this session today. We're starting unit 4 on dependencies, and we're actually going to get into more software design stuff. So far, it's been pretty light on the software design. We've been talking about just general things, how to use GitHub, what is Scrum, and that sort of stuff. And the first couple pages of the text are set up that way. Oh, and let's bring up the textbook here also. And so, but this is the first time we really get into some of the Scrum, not Scrum, software development issues. There's a lot of stuff on this chapter. But the reason is that it introduces a lot of things that we'll spend the rest of the time on. And so we'll be going over stuff today that briefly that we'll spend chapters on later on for this. I'm going to change this text on this screen. It looks like it's a little small. Let's try that. Okay. So, let's kind of jump into chapter 3. It talks about dependencies and layers now. I think some of you hopefully ran into some issues with the sample sprint where you had to edit code that the same code file that someone else had to edit. And often you might pull the code down and the other person pulls the code down. And then over a couple of days, you make your edits. And then when you push the code up, your edits will conflict with the other person. You're both editing the same file. And that's a real common issue. And there's a struggle for how to get that fixed in different places. And so one thing that's often done, and just, the whole idea is, when you're changing some code and someone else is changing the code, how do you manage that? We generally like to try to, in some ways, compartmentalize code so that everyone's not having to touch the same code in large projects. And so that's what we're kind of looking at, is how do we structure large code projects that have 20 or more classes, maybe even 100 class files out there. And how do we manage dependencies when we have so many class files and then one is dependent on the other one? How do we manage that? So that's what we're really kind of looking at today, is the motivating factor of that. And so I'm just going to highlight some things. I really recommend reading this chapter in detail because I think it goes over this very well. I will highlight some areas that you can skip on this chapter, but talks about the dependencies. And when does some software depend on another? And this talks about a client service, but this is really anytime an object uses another object, instantiates, does new, declares a variable that's another object type. So anytime an object uses another object, it depends on that object for it to work. So we're going to look at a simple version of this. And I don't know, I think you can decide. I'm going to go through and create this code. I think it's helpful sometimes for you to create the code along as we go too, so that you can see. Now the code's provided in Brightspace here. Oops, let me move. I'm going to move this up. There's part 1 here. That's the code we'll be doing. Move that up here. Okay, so in this dependencies part 1, the code's here in these files that we'll end up with, but we'll build it up slowly, and we'll talk about that. And it's largely the same code that'll be in the chapter here. So feel free just to follow along. So I'm going to go to Visual Studio. I'm going to create a new project. And we're going to create a console project. And the book calls it Simple Dependencies, so you can name it something like that. Okay. Now, I'll warn you that this chapter of the book is from the first edition. Well, this is the second edition, but it wasn't updated in the second edition. So this is actually using Visual Studio 2015. So some of the stuff in here will not be exactly what you see. And there's a lot of screen captures of Visual Studio in this chapter. So we'll go through and we'll do it in Visual Studio 2019, just so we can see it there. Okay. So we've created our simple dependency console application here. And it talks about these references and this reference folder here. Now, it is now called dependencies folder here. So we see a dependency folder here. We have our project. Here's our code, our C+ our C# code file program.cs. It has our main program in it. And then under dependencies, this is where we'll see your different dependencies and how they're set up here. And right now there's just one dependency. Microsoft has streamlined their dependencies a lot and used to have a whole bunch of dependencies in here. And depending on how you set up the project, you will have more dependencies in here. So it's showing references here, but now it'll show it as dependencies here, just so you know. And then they want you to do a slight change of the code. I'm going to do this also. It's not. So right now we do a console write line, and then we're going to want the program to hold there and keep running so we can see different things. So we're going to put a read key afterwards. And so that'll work for any key. So I'm just going to change this to say hit any key to quit or something like that. So a program will just run. It'll say hit any key to quit, and it will call this read key here. So again, we're just following around with the textbook here, and they want us to run this and see what modules are loading up when we do this through this certain window here. So let's try this out. So I'm going to run this. Just the console window should pop up. It should say, oh, hit any key to quit or whatever you typed in there, hello world or whatever. And it's just sitting there waiting for me to hit a key. So while it's sitting there, I'm going to see, I can see what's running. So I can go to Windows or debug Windows and modules. Now, when I'm on my other computer with Community Edition, it doesn't seem to have all this stuff built in. So if you have the Community Edition, does anyone have the Community Edition out there? I'm thinking you won't see modules. And again, it's not a big deal. This is one of the few times where I know that there's something I think that's not in the Community Edition. But what the textbook wants you to see is that there's a bunch of libraries that are loaded up and run when you run your program. And again, this is a pretty small list, but when we make more complicated applications that use like web and database stuff, there'll be even more. And these are DLLs, dynamic link libraries. So, and we'll create our own in a sec that'll run here. So this is the dynamic link libraries that are running here. And so our program is dependent on all those libraries, even though we don't explicitly say. So we're going to talk about that in creating our own dynamic link library for message printing. But before that, let's create let's just talk about how we structure code in here. Let's add some other code. Let's say we want to control who prints. And so we want some accounts. You have to log in to print and run the print services, which we're going to get into. So we want an account controller class there. Now, where would we put that? We could just put it here, but we're going to end up having, for our accounts, we're going to end up having, I think, 5 or 6 classes, including an interface, all related to accounts. And so rather than putting them all here, we can put them in a folder. So I'm going to go up to Simple Dependencies, and I'm going to do Add New Folder here. And then I'm just going to call that the Accounts folder. And then I can put a class inside that folder. I can add an item class, and I want to make an account controller. This is just going to be the main class we're going to use to control user accounts and access user accounts. So we're going to call it the account controller because it's going to be kind of in charge of all the accounts. Okay, so I've got that class inside a folder, and then this is my main program here. So this is a common way of structuring code. Like we just saw the last model view controller example you worked on. The models were in one folder, the controllers were in another folder, the views were in another folder. So this is common stuff. But when I build this, all this stuff has to be compiled. So if I go up to build, everything's built together. And again, right now it doesn't take very long, but again, with bigger projects, this could all, it would all be relied together. And again, maybe when I update some part of this, the other part would have to be updated as all kind of shared code. And so sometimes we don't want that. Sometimes we want to segment it off. Often, like if we're at a sprint and we have a group of students, let's say, not developers, maybe we have 8 to 12 developers in a group. They might all work on the same project, the same code here in the same way. And there's enough there where you can manage who's editing which file and what version. You're all going on the sprint at the same time, and you're all getting things released at the same time. But if your code's bigger than that, where you'll have maybe 3 teams working on the same product, they might be running a different sprint schedule than you are or something like that. So they might be updating things differently than yours. And so some of the code might not be buildable while you want to build yours. It might take a long time to compile. So what we'll do is we'll break this up into different parts. And to do that, we'll make different class libraries for this. So we're going to do that now with print services. So that's what they're arguing about, this print services. We're going to put this in its own class. So we're going to make a message printer project out here. So now how do we do that over here? So right now we have a solution here. Go to solution and say, we want to add a product, so I'm going to go down to add and add a new product, not product, project. Add a new project. So again, I have to be clicking on the solution level, not the project level. So click on the solution level, go down to add and add a new project. And again, we built a console app, that was fine, but now we're going to add this class library. So scroll down here until you see class library. And that's what we're going to add is a class library. And we're going to have this be the message printer library. I'm going to create that. So now we've got 2 things. We've got 2 solutions here. Our simple dependency solution, which has our main file in it, and our message printer, which will have this, which just has by default just class 1 in it here. Now you may notice that one's bolded, this one's bolded, and this one's not. In any solution, our solution can have multiple projects in it. Each project compiles separately, and one of them has to be marked as the main project so that when we run this, it goes to whichever one is marked as the main project and looks for a main program in there and runs that. So one of them, that's the bolded one here. So here, let's just add, let's go into the message printer area. We've got a class there. I'm going to add another object. What's this object called? Message print service. We'll do that. So I'm going to go to there. And again, now I'm clicking at the project level, not the solution level. I'm doing add, And now I can add a new item that's a class. And I'm going to add this message printing service. Now I'm going to be adding some of this code, and I'm going to be copying it sometimes right from the textbook so you can see where. Now, if you don't have an electronic version of the textbook, inside the text here, I mean, inside Brightspace, oh, I don't have the link to the whole project here. Let me grab that real quick.
So what's the point of putting this stuff in dependency?
Well, it'll compile and build separately. So here, let me edit this. So okay. But the code segments are also right here. So here's the message print services that we'll have. So if you don't have access to electronic book, you can just grab it here. And so again, we're going to add this constructor here inside our core code. So I can just grab that there and put it in here as we go. Yep, listen.
That link says we need access.
See if that solves the problem. All right. Okay, so we have this message printing service we just added. And so Chermak was asking, why do we make another solution in here? And how is this structured? So that's, well, first I'm going to compile this and show how we have to build this. So let's say we want to call print message from our main program. So I'm going to go into our main program here. And in order to call print messages, I have to make something of message print service type. So in the main program, I'm going to say, I'm going to declare a printer, and I'm going to instantiate a new message printer and call the constructor there. Let's make this a little bigger. So I'm declaring an object of this type, calling it printer, and then calling the constructor. But again, that's not finding it. And it's probably, and even the hints don't provide really good hints. It wants to generate its own class. But this is in a different namespace. So generally what we have to do then, in order to get that to work, we have to use that namespace. So we'd have to say using, good typing, Tom. There. And then that would let us figure this out here. But that's not working either because it can't find that namespace. But I'm going, that namespace is right here. Message printer. Why can't, maybe I have to save it. Saveable. No, that's not it. It's just not finding it. And the problem is that it's in a different solution or a different project than ours. And so we have to set up dependencies. So if our main project here is referencing another project, we have to set it up as a dependency. Okay. So once we've got this other solution, other project set up, we're going to go into our first project, go under dependencies, and I'm going to say add a project reference. And by default, it shows ones in my solution called message printer, and I'm going to add that. Now, eventually, we'll talk about how to add lots of other references to other libraries that are built in here and stuff like that. But for now, we're just going to add our own message printer reference. So now under dependencies, we see it's dependent on this framework, and then also under projects, it's dependent on the message printer project here. Okay, so now this should work. We still run into problems because of inaccessibility. I didn't declare message printer right. It should be a public class so that it can be accessed by people outside of this project. So make it a public class, and then everything should be happy. I should be able to run. Oh, I don't have a new. Okay, yeah, there. So I should be able to run this, and it should say print hello, or whatever I have it saying. Is that what happens? Oh, I'm actually not calling print message. Let's actually call cell printer dot print message. Actually do something with that. Okay. So it prints hello world and then prints any key to quit. Now, while I have this running up here, if I go to debug, window, modules, I see a new DLL loaded up in the memory, and that's the message printer DLL. So this is a new library that's running, that's loaded up. So it's loaded up that extra library here. Now, let's look at how that's structured. I'm going to go run a file explorer, and where is this stuff kept? I think it's that I have it in C, users, T givens, source, repos, and simple dependencies is my solution. And so each of these projects has its own folder here. Inside simple dependencies, there's a bin folder, and inside that is debug, and inside that is nothing because I'm not running this. Let's go back and I'll run this. Now, let's see. Oh yeah, I had to look inside the netcore stuff. So simple dependencies will create an exe file that's running. So that's what this is, an exe file in here in the debug folder. And that's what's actually running out here. And the message printer, so this, let's see, actually let's stop this. This bold one, since it has a main, will be converted into an executable, an exe file. This message printer, since it is just classes, a class library, it'll be compiled into a DLL library. So that's why I see this message printer DLL that's built. So that means that I can have one group of people working on this the message printer stuff and compiling that separate and just give me the DLL. So I could set this up so I'm really just importing the DLL here. And so allowing these class libraries lets you split the code up among teams and then share the DLLs. Different projects will compile and create a DLL that they can give another group of developers and work with. Now, DLLs are very specific to Windows and .NET stuff, but Java has the same thing. What do you think? Have you heard of what's a Java library? Have you guys created Java libraries before? No, may not have. So there are. Have you had to work with jar files? Because DLL are the same as jar files. So you may have had to work with jar files. somewhere. And so in Java, you create a class library and you compile that into a jar file. And a jar file is like a DLL. It's a precompiled set. Let's say it's a precompiled set of code. In Windows, we precompile it all the way down to low-level code for Windows. In Java, we compile it down to what's called bytecode, which is still a little higher because it's still machine independent, but it's compiled down to bytecode at that level. So again, in Java systems, you often will share Java code or have to import Java code or Java jar libraries into your projects and stuff like that. So. Okay, so that's one way to segment code into different parts so we can compile it differently. Okay, I'm going to go back to the textbook. So that's what they're trying to show with this whole message printer stuff and using it here. We also talk about framework dependencies. I'm not going to talk too much about that. Microsoft's doing a better job, but again, in Microsoft, every product is dependent on certain frameworks. It used to be often when you install a program that you downloaded from somewhere, you may have to also install some .NET libraries. And that still might be the case. So there's different versions of .NET and things out there, and sometimes that's an issue. Okay, I'm going to skip over this whole section on default reference lists and that sort of stuff. Third-party dependencies. Let's just talk a little bit about third-party dependencies. Often you'll bring in other dependencies, and we'll talk about one later on. So I'm actually going to skip it here and bring it up in a little bit. So how do we model this? We model this with a graph. Generally, we use this directed graph. So this would mean A depends on B, B depends on D and E, and shows dependencies that way. The arrows show dependencies here, but it says, so B is not dependent on A, but vice versa. I don't know, when you're installing software, a lot of systems have lots of smaller software components that have to be added together. I'm thinking of like Python libraries, if you worked with Python. Unix systems have lots of small components that are added together. And so often this whole dependency graph and things like that gets very complicated, especially when you have different versions. So like in the machine learning course, we install TensorFlow library, and that's dependent on another library, and that's dependent on like 3 other libraries, and those are dependent on about 20 other libraries. So there's this whole cascade of about 25 libraries that have to be installed so that you can use TensorFlow. And so there's usually, a lot of systems will have what are called package management systems. In Unix, there's a couple. There's the apt-get program there, and you type apt-get and a name of software, and it will get it and all the dependencies. Python has a similar process of managing dependencies and stuff. Has anyone run into, I mean, I run into it fairly often, but I don't know if you're using that software so much. So have you guys run into any package managers or having to install different versions of different software? How's it going out there in Zoom land? You guys awake out there? I haven't heard from anyone. Maybe I don't have the volume up. Maybe I'm just ignoring you. I have the volume up. Oops, but where is it going? Let's try this again. That's tall. Okay, now, since you guys are talking so much, I'm sure we'll hear you better. Does anyone use any what do you see, a package library, ever use packages? A lot of no's out there, it seems like. So. I'm going to skip over some of this other stuff about types of dependencies and things like that. We're just not going to go over that. We're going to skip over this about cyclical dependencies. recursive dependencies. We're going to skip over all that section. That's just not that important. We are going to talk about these patterns and anti-patterns for managing dependencies. And basically, a lot of this course is set up that way. How do you structure your code so you can manage all these dependencies? Bad software systems get set up so that as you create more and more code, it's more and more interdependent, and it becomes almost impossible to make changes to it unless you're following the right ways of structuring your code. So the good ways of structuring code are called patterns. The bad ways of structuring code that are commonly used are called anti-patterns. And we'll look at a number of patterns throughout this whole course. So we'll also talk about interfaces versus implementations, and we'll go over our first one here. And then I think the whole next chapter is on interfaces. The textbook likes some anachronisms, some references to different things. So they talk about code smell. So if code smells, if it's just not structured very well, it's just not good code often. It smells bad. So, okay, so we're going to work on our next example here, talking about how to set up code and structure it in different ways. And so we're going to look at this account controller class and look at dependencies. So we're going to create an account controller class, and then we're going to put some code inside of it. So let's look at our project now. So we worked with a separate solution message printer. We're going to leave that our own, and now we're going to go back to just our own little simple dependency project. We have our main program here. And we already created an accounts folder and an accounts controller class within that. And now we're going to put some code in there. So we have public class account controller. And I'm just going to grab this code and stick it in there for now. So this is the textbook version. Now, this is actually set up in some web system where you could put service calls to a system called a REST API, RESTful API. And so I'm going to delete that for now. So let's try to set this up, and we're going to need to use some other classes here. We're going to need this security service class here. So if I look, let's see if I can have that just create that class. It's one of the options is generate the security service class in a new file. I'm going to say do that. So it'll create a new class file for security services here. Similar for user repository. I'm going to click on that and have it hopefully generate a class with a user repository. And then I'm going to have users as a special type. I'm going to need a user class. I'm going to generate a user class as a new file. Okay. So now I'm going to have inside accounts, I have 4 classes so far. Account controller is my main controller for getting things. It uses security services to access certain the system's security things, how to create accounts and that sort of stuff, change passwords and stuff like that. We're going to work with users, and so we're going to have a user type, and we're going to pass users back and forth. They'll probably be stored in a database somewhere, but we'll just inside our code put them in a user repository, which will have a list of users in it, an array or a list of users. So that's kind of would be the structure that we have set up here. Now, what we're trying to get at is all the dependencies. So if we had a structure like this, what would be dependent on each other? So if we have it set up this way, account controller is forever dependent on security services and user repository. So the account controller here, it creates a security service and instantiates that object. It calls that constructor. Same with this user repository. it creates an object of that type and calls the constructor and instantiates that. And so account controller is always going to be dependent on these two things for this. And again, this will cause us trouble for a number of reasons. It's going to make testing very hard. We're going to want to unit test this. So in unit test, we just test out this one class without any other classes. But we are instantiating an object here, here, and here. So how do we test this out? How do we test this code out without these classes? And so a lot of this stuff we'll be doing in this course, we'll look at different ways of getting rid of, rather than instantiating these classes directly, instantiating an object or passing in an object that serves as a reference or stuff like that. So often we'll look at account controller having a constructor and then passing in a security service as a constructor or something like that, or different ways around it. So we'll look at ways of setting this up differently so we do not call these constructors. So now that we have that dependency, any dependencies that are later on here that these objects have, account controller will also have for this. Let's look at, and again, I talk about extremely difficult to unit test. The two classes are impossible to mock. So we'll talk about mocking. That'll allow us to create a fake security service for testing purposes, or a fake user repository with have fake users in it for testing. And the way this is set up, we can't do that very well. So, well, we can't really do it at all. So, another issue we have in here is a user object. There's this user object here. We get a user from the user repository, and we send that to this security services. So we have these two main objects here we use, and we get a user from one and send it to the other. And again, like we have basically what it's done, it has made all these four classes interdependent on each other. Account controller is dependent on all three of the other ones, and because it gets a user from the user repository and send it to security services. So that's going to be an issue. Let's add this next piece of code. Let's go into security services and we'll add this code into security services, the constructor. So security services has a default constructor. No, it doesn't. Yeah, I'm just going to grab this whole constructor and move it over there. Okay, now security service has a constructor here. Now, you may not recognize this session factory, but if you've done a fair amount of database programming in some different codes, this is actually a call to a library called nhibernate. Hibernate is an object relational mapper. It's going to let us take SQL commands like, select, go out and get something for the database and map those into objects. So we're going to have objects here like a user, we have a database that'll have maybe customers or users in it, and we can go query the database, get all the fields in, and then map those into a user object. And that's done a lot. And so there are libraries set up to do that for us. And nhibernate is a really common library for doing that here. So even though we don't specifically say or declare an nhibernate object here, this security service is dependent on the entire nhibernate library system here. So we'd have to install that as a dependency and bring that DLL in here to get this to work. So, and now we're getting to this point of the graph. I'm going to go back up here for a sec. That's not that one. this one where we're getting our, so A would be like our account controller, and it's dependent on our user repository and our security services. User security services is dependent on users, and also this whole N Hibernate library. So I mean, we don't have any code here at all, and we already have this many dependencies in our code. So that's what we're kind of arguing is we gotta be careful. It's okay to have some dependencies, but we want to manage them. We want to try to set up our code so it's somewhat independent of other code. So, and again, it talks about this lack of testability here for our code. And again, we'll I don't know how much you've done on unit testing, but we will do a fair amount of unit testing in this class and setting up unit testing and mocks and that sort of stuff. So this will make more sense once we get into unit testing later on. So what it's saying now is there's no way to test out account controls without having a database connection, because security services, it's dependent on that. It creates a security service, and that creates a database object. This needs a tie to a database. And so we can't connect, we can't even test this out without having a full database connection, and that's bad. We'll want to be able to test out our program without access to the database. And so we'll want to create a mock, a fake interaction with a fake database in these. So it also talks about this inappropriate intimacy issue here with the user. And the idea is that, so let's fix that. Well, yeah, we'll get into, let's fix the user stuff. So I'm going to go back to account services. I'm going to comment this out because we're not going to ever install the N Hibernate stuff. So this needs N Hibernate. And we don't have that. Okay. So now let's go back to our main program. No, our account controller here. And again, our issue was with our users. We're going to our user repository. Let's get this to compile as is first. So right now we should have a user, our constructor here should return a user. So if I go to user repository, there's not a constructor here. I want one created. I think if I go to accounts here, I can actually just tell it to create one. No, that's not what I want. Okay, let's go into user repository and create a constructor. Let's see what. Oh, I think I don't want this code. Well, I don't know what code this is, but I'm going to change this code around. I'm going to create a user repository and call it like repo. I'm trying to match this up to what I did in this section. So let me just go over and see how I'm doing over here. Change password. Oh, we're going to switch that all around anyway.
That looks different than yours.
Yeah, so I'm just going to set this up, and then I'm going to change this back to, eventually it'll be what's shown in here. We just have to get to that point in the textbook. So there. Okay. So in user repository, I'm going to add a method called getUserID that's going to take a user ID and return a user. So not an object, but a user. Let's see how that works. And then change user password. I'm going to add that to that method. So let's see how I'm doing here. I think I is now compiling. Account controller creates a user repository here. It uses the user repository to say get ID and passes in the user ID. So user repository gets a user ID, and it should look up that user in our array or our list and return that user object. It should return a user object. We get that user. I'm going to declare that as a user type. And then once I have that user type, I send that into change password and give it, tell security services to change that user's password. But again, I'm passing this user around, getting this user and passing this around here. And so we're going to change this. Let's look at what the textbook suggests. We have this inappropriate level of intimacy with this user instance here. So change password and user repository class, retrieve a user, and then we send that to security services. So we're going to change that around so that we're only going to pass the user ID around, not the whole user object. So what that means is that some of this code is going to move where we get the user and stuff. We're going to move that out of account services, and we're going to put it into the security services, change password stuff. And then into change password, rather than passing in a user, we're going to pass in a user ID. So I don't know, I'm trying to see if you can make this sense. So we were creating a user and passing a user around here. So inside account controller, we had a user ID. We went out, got the user, and then we sent that user to change user password here. But we don't necessarily have to do that. We can just pass the user ID. So sometimes when you're setting up your code, you got to ask, when do I need to pass an object, and when can I just pass like a key or a user ID, or user ID is a text field or something like that from one place to another for this. And that's why they're trying to set it up this way. So this is what they should end up with, and I think this is what we'll have posted here, although we're going to introduce an interface which will change things in a little bit. Okay, let's talk about alternatives to object constructors. So inside our code here, again, we're calling a constructor here where we're instantiating an object. And again, we're generally going to want to avoid that here. Now, we have moved some of this around in that the user repository stuff is not in the account controller anymore. It's in security services. But again, security services is still instantiating an object. So what can we do to not instantiate an object? There are very complicated ways to avoid that. And then chapter 12, we'll look at those. But we're just going to look at using interfaces to at least make it a little less tied together. I often think of things that are hardwired together. I don't know if you have you ever taken apart your tablet or your phone, like maybe like your USB, like the little plug in your USB cable. I suppose you can't even see that. If that on your tablet is broken, and some tablets, you can open up your tablet and that whole part can just be unplugged. and you can buy a new one and plug it in. But in most phones and most tablets, it is soldered in place. So in order to, if your USB thing is wiggling or loose, you have to like unsolder. It just, I don't know, I can't do it. I'm not a good solderer. So, you know, it's hardwired in place. It's not just a plug to take in and out. And so there's a lot of places in hardware where things are just hardwired together rather than plugged together. And that's kind of the code equivalent here. When we're creating this new object of this type, it's basically hardwiring this together. And what we want to do is we want this to be more of a plug where we can swap in a different thing for this security service. And that's what we're going to use an interface for. And again, we'll do more interfaces next chapter, but this is just a real basic introduction thing. So we're going to stick in an interface in here for security services. So right now we create a security service and we call change password. So that's the only thing we use security services for, is to change the password and use that one method. So we're going to convert that into a plug, an interface. Okay, so here's an interface we're going to create, is the iSecurity interface. So again, over here under accounts, I'm going to go add a new item. But rather than a class, I'm going to go down to interface. And again, it's kind of showing this plug. And then the name interfaces always start with the letter I. And so I'm going to call it iSecurity Services and create that. And now we just list what methods that security interface should implement. And it only has to implement what's one, this change user password method here. So here's our interface. Let's copy that here. Where's that interface? Okay. Let's see if this is matching what I have now. So our interface is void change, yeah, user password here. And we're passing that. So we're saying that in order to do this, provide a security interface, right now you just have to provide one method, change user password. Eventually we'll probably add a couple more methods. Create a new user, maybe delete a user. Maybe those are the three things we need to do for users. Create a user, delete a user, and change a user password. Well, we probably need to check that the given password matches the stored password. So maybe 4 things eventually. But this is our one thing in our interface here. And now how do we use that interface? In our main program here, account controllable, the account controller, right now we declare an object of security services type. We're going to change that to an interface. We're going to say iSecurity interface. And so now we'll declare an object of the interface type. But in order for this to work, our security service must implement that interface. So I'm going to go to security services, public class security services. I'm going to say colon, and then the name of the interface, iSecurity services here. So it has to implement that interface. Now, in order to implement that interface, it has to declare the change user password, but it does already. It already implements that. So this is a common structure here of declaring an interface that sits between. So now we have an account control. Here, let me set this up this way. So again, we have our account controller and our security services, and they used to be tied directly together, where this declared an object of this type and set that up. And now we put this interface in between them. So now account controller doesn't have to know as much about security services, and we can swap those another security services out technically, we still have an issue because we're still saying new here. And we shouldn't. We're declaring a security service object here. So what we'll look at eventually is in our constructors here, we'll pass in a security service, a service of this interface type, so that we'll actually get rid of this altogether. Okay, but we're not, I don't think the textbook gets that far yet in this. It just introduces this interface at least. Now, because this is such a common thing, most IDEs actually have a shortcut to do this sort of stuff, to take an object and add an interface in between it. I haven't, let's just look, I'm gonna look. So another place where we could do that is security services uses the user repository here. And this is not an interface either. We don't have an interface there. So if I look at quick actions, I'm just wondering if there's an option here. No, let's see, is there an option here? Yeah, I don't see it, but and maybe I'm thinking of Android Studio, not Visual Studio, where they have a quick option to pull things out and put an interface between two classes. Because again, we do that so often. You'll do that dozens of times in this course alone as we go through things. So. Okay, so I'm sorry if this is kind of, I always think this is kind of a confusing chapter because we go over a lot of this stuff. But remember now, we'll spend a whole week next week talking about interfaces and revisiting this one sample thing here. So a lot of this stuff we'll spend whole weeks on later on. So again, we're just kind of doing a quick survey on how to do some of this stuff here. And I was talking about ways of not instantiating an object. And again, we'll spend whole weeks looking at different patterns for doing that. So I guess what I'm saying is it's okay. I would read through this chapter again, but it's okay if you're still kind of confused at this point. Because again, it does a kind of quick intro to a lot of stuff in this chapter. Okay. I think just walks through the same code. It introduces an interface here, make sure our security service calls that interface, and then changes this code so it uses that interface here. And one thing I find, that's why I like to actually do these changes in front of you sometimes, is that I find when I first read this, I'm often going, so how is this different than this code up here? And I'm scrolling back and forth going, what's the difference? And then if you don't know what to look for, it's sometimes hard. So that's why I try to show you that what they're doing is they're taking this code and the way this code is structured, and they're adding an interface to it or something like that. So then hopefully now you can go through and read this, and it will hopefully make some more sense. Now, I was mentioning that we still have this problem where we're instantiating an object here. And so there's a whole thing on dependency injection. And chapter 12 is entitled dependency injection. So there's a whole chapter on how we can get rid of that stuff. But we'll also look at some other ways besides dependency injections to get rid of these objects instantiations here. So, so I'm going to skip over this dependency injection stuff, I think, and how this is set up. They're talking about setting up the user repository here, and how well, maybe we'll do this, because they set up, I don't have this in this code, but they set it up here. They created an iUser repository also. So again, we did between accounts and security services, we did an interface there. But we could also, under security services, it creates a user repository object, and we could put an interface in there. So I guess I'm not going to do that, but that's what this code, I'll just go over this code and talk to you about it. They're creating a user repository interface here, and creating an object of that type here. And then their constructor here, they're passing in one of those objects. They're passing in a user repository into here. And again, that's a common thing we'll use often, is we'll declare an interface, and when we'll give that, so an object will be given in a constructor, will be given all the objects it needs to do its work. So we could say, okay, here's a method for creating users. Here's a method for an object that lets you access the database, and we'll give those to you in the constructor. And then you can use those. So often in our main program, we'll create a bunch of objects and we'll pass those on to all the different objects that need them here, which will make unit testing and some of that stuff easier to work with. So I'm going to skip over some of this stuff with assemblies and this common runtime language, just-in-time compiling stuff. Again, that's somewhat specific to Visual Studio and .NET stuff or Windows stuff. And Java has similar stuff with compiling and jar languages, where Java compiles down to what is called byte code. Here we compile down to CLR, which is, both of them are low level but not machine level things, and then both of them have are kind of run can be run on the machines and can be run on different hardware with this just-in-time kind of interpreting of these languages with some like a Java virtual machine type stuff. So I'm gonna skip over this whole thing with fusion logs and how these things are stuff and how this has worked. I'm not going to talk too much about these services here and service discovery much. There are ways of setting up this so that you can access code that right now we're working with DLLs, but you can set up code that's not set up as DLLs that you can access in different ways and so, through these services. But again, we're not going to go into that detail for that. We will stop and talk a little bit about RESTful services. So especially if you're doing a cloud-based system, RESTful services lets you create code in different locations on different web servers and then access them in different ways, and also discover what services. So you can go to like a web service and do a request for what interfaces, what things do they provide to you, and then you can call those RESTful services in your code. And again, we'll look a little bit about that. I don't think we do that much in the server-side class. I think server-side is mainly one server and PHP stuff. I think still on server-side. I don't think, has anyone taken server-side recently? I haven't looked at it since it's been updated last. You guys are no help. Okay, so again, with RESTful stuff, you can query a server and ask for stuff and get responses for them. And again, I'm not going to go over the details of how you can do this, but again, you can query a web server and you use the HTTP requests and stuff to get information from that stuff there. And it looks complicated, but once you set it up, it is really not that bad. How you use these HTTP requests to request stuff from a website. And We'll see if we get a chance to do an example of that in this class. So I did talk about package management stuff, and Visual Studio has their own called NuGet for dependency management and setting up packages. And sometimes you'll run into problems where you'll be trying to build certain systems. I often run into it because sometimes students have a different version of Visual Studio than I do, and they'll be working with different frameworks, and they'll send me an assignment, and I'll try to build that assignment. And NuGet will try to load in the right packages in the background. And NuGet's running in the background a lot of these, and it will have trouble because I won't have certain packages installed or ready to go. So sometimes you'll see NuGet pop up a message here, and where you'll have to install certain packages for it. Lately, I've not seen it near as much of a problem as we did back in 2015 when this was released. So I'm going to skip over much of this NuGet package stuff for this. So let's talk about layering, and because we'll get into this. So when you start getting in lots of classes, how do you organize them so they can talk to each other and not have them all in a big mesh where they're all calling each other and things like that? We often want to try to isolate a certain group of classes together. You kind of think of it now with the pandemic, how you can take a small group of individuals that are all working together and isolate them away from everyone else, and then just limit the interactions from one group to another group here. So think of classes the same way. We want to create a set of classes, like maybe here we have this account classes. We want to create that account class, and we want to limit it. So maybe the only way people access the account class is with this account controller. That is going to be the only public class in here. And everything else will be internal or private classes for that. Common ways of setting these up are to push your user interface on one end, push your database on the other end, and have some control logic in the middle. So we generally call the user interface the views. So it might be a set of web pages, it might be some screens, it could be any, but we always just use the generic term views. The database models we often call models, because the database models. So that would include like the user or the product, anything that would be mapped to tables generally in your database. You'd have classes for that. And then you usually have classes that would have a collection of users or a collection or a list of products or stuff like that. And then you usually have a controller and something that helps map to the SQLs for all that. So that's all in the data model stuff. And in between has a controller, and that will go to the database, the model, get like a user or a thing, and then bring it back and then send it to the view for display. So this is often called a model view controller interface, but there's different versions of that. This is a view controller view model interface that we'll set up. So that's another one, view controller view models. And so view models is a little different than just a normal database model that's out there, and we'll look at different ways of setting this up. In fact, we'll have, like I said, we'll have a whole chapter on what is a model view controller, what is a model view model, what is, and I think there's 4 different structures we'll look at in that chapter. So this is just shows you one.
We're gonna have so many chapters on this stuff. Why don't we do those chapters first and then do this?
I guess we're just going to give you a preliminary warning that this is coming up, okay? So this is the, before you watch the movie, you watch the preview. This is the preview clip of the rest of the whole course. The other way is, so those are kind of independent. They're not necessarily labeled here, but there are other ways where we do layering in tiers. Again, so they're showing user interface, database access, user interface, database interface, and implementation here. and setting these up. Often what we're worried with is we have to what is called serialize the data. So you might have a complex class. In order to store that in a database, we have to serialize it, convert it kind of in a text format, or even if we're storing it in a file or an XML file, set that up. So here's our 3 layers: user, business layer, data access. There's another way, and again, user, the data model, and then we have this object relational model. This is where the SQL commands come in, where we're taking our user objects and converting them to SQL and sending them to the database, pulling queries back from the database and converting them to objects here that we work with. So, and again, we'll look at different versions of this stuff. So, and that's why I guess I'm skipping over a lot of this sort of stuff because again, it just tries to show you a quick introduction to what we'll be spending chapters on later on. Okay, so I think our code here is pretty close to what we have here as far as the setup goes. And then in class on Thursday, we'll have you do an activity with a simple model view controller and a weather app, and have you try to create that and set that up. So I have it hidden here because I haven't updated it to Windows, to Visual Studio 2019. So tomorrow I'll update that, make sure that's updated to Visual Studio 2019, so that Thursday it'll be ready for you to go with. Sounds good? I think we're ready to wrap up. Someone on Zoom just wants to say hi to me or say a word. I just feel like I'm like, one of these hosts who has to have real people out there.
Hello.
Hello.
Hey, there are actually students out there. Cool. I like the thumbs up. That's what I should ask you to do, more thumbs up. I'll have to use that. So, okay, I'll stick around online if you have any questions to do. I suggest you read through the chapter now, but that's all we have for today. Sorry, I went through this whole chapter in 1 hour.
So if I feel spring go on like Thursdays, then I can just go read for them.
Right, yes. Sounds good.
Okay. Oh, it's my birthday today, Tom.
Happy
Thank
birthday.
you. I'm 22. I'm old.
Wow, you are so old.
Yeah.
Oh,
I'm having a
how do you
quarter
not
life
have your
crisis.
whole life figured out and
I
everything
don't know.
planned out?
Or
And
like-
how do you not have a job by now? You're already
Trying,
22.
Tom, okay, gosh.
Jeez, my
Do
son,
my best.
is, I think he's 28. He doesn't have his life figured out yet
Oh,
either.
thank
So
God.
you got six
At
six
least
years
6
just to
years.
coast before you even have any. You don't even have to worry about anything for at least 6 years. So, there I have some today. Right after this class. Oh no, at noon I think. After this class, do you want to and tomorrow? When do you want to meet sometime, or what do you want to do? So, are you free? Let's see, where's my calendar? Yeah, I usually just go up and eat lunch, and then I have office hours at noon. Does that work, or do you have another class?
No, after class.
What?
After class, I do after class.
You do have a class?
Yeah.
You want to just meet now, and I can have lunch later on.
I mean, now I need to bring the stuff on the show. So.
Okay. So when?
I mean, it mustn't be today. Like, I just want to know.
Okay,
Like, I need
tomorrow
to-
morning at 9,
Tomorrow morning at 9. After class at 9:50.
9:15.
Yeah. So we
Um,
can do. I think Thursday will be good. I'll be there on Thursday.
Thursday?
Yeah. The class I have another time. 8 o'clock. He
Okay,
sends us like videos for us to watch.
Right,
So he
okay.
will meet us once a week. So
Right.
Thursday will be free.
Thursday? Okay, so we can do Thursday. Sounds
Okay.
good. Okay, great.
Thank you.
Yep.